Alright, I'm going to do example 17.1. Here we're looking for a t critical value. The question is, for a t distribution with 9 degrees of freedom, what point on the distribution has probability 0.05 to its right? I'm going to do this 3 different ways. The first way is by calculator using the silver addition. That's the best method, or the one that I like to see people use the most. If you do not have a silver addition calculator, there's a program that can be installed. You can see me or the mark to get directions on that. The next method will be using an internet site, and the third method will be using the table. First, again, we're looking at a 0.05 to the right, 9 degrees of freedom. In the calculator, I'll do a second distribution. Oftentimes students don't know if they should use an inverse or a regular, so if they should use a t-CDF or an inverse t. Just like the normal distribution, we used inverse norm if we were given a proportion and asked to find the horizontal value. We're given a proportion of 0.05 and asked to find the t value, so we'll be using the inverse t. Again, non-silver edition calculators do not have this program. You will have to install this program or use a website and the tables to do this. I enter 0.05, that's the proportion to the, let's see, it was a 0.05 to the right, so that means there's a 95 on the left, 9 degrees of freedom, and hit enter, and there's our solution, 1.833. Usually t values we round to 3 decimal places. The next place, I just did a Google search and I found this program. I entered 0.05, 9 degrees of freedom, and hit calculate. I'll get the same answer if I do 9.5, 9 degrees of freedom, and hit calculate. Oh, I guess I don't. Let's see. Oh, reading the directions, I do need to put the proportion on the left, and that's what's going on there. So, and it's a one-tailed value because that's how much is just on one side, not on both sides together. The third way will be to use a table. This is the table that will be provided during the exam. Going over the one-sided p-value of 0.05, and I go up to 9 degrees of freedom, and I get the solution of 1.833.